Hello, I welcome you all to this another interesting screencast, and in this particular video we are going to be solving this problem that reads a railroad car having a mass of 15 megagrams is costing or moving at a speed of 1.5 meters on a horizontal track. At the same time, another car having a mass of 12 megagrams is moving at 0.75 meters per second in the opposite direction. If the cars meet and couple together, determine the speed of both cars just after the coupling. Find the difference between the total kinetic energy before and after coupling has occurred, and explain qualitatively what happened to this energy. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by RC Hibbeler. So let's draw the two cars. So we have one car, like so, moving. Let's imagine it's moving to the right along the track. And we have another one to the left along the horizontal track. Right. So we have this. Okay, so let's say these are the reaction forces. So this is at upon the time when they meet. So we have F here. Then we have minus F, like so. Okay. So let's call this VA. We call this A, car A. Call this car B. So our VA here is 1.5 meters per second. It is in this direction. Okay. So this is VA is equal to 5 meters per second. We have car B is equal to 0.75 meters per second. In mass for car A is 15,000 kgs. Mega is 10 to the power 6. Car B 12,000 kgs. Right. So we are using the principle of the conservation of momentum, described as the summation of the mass for all the systems involved times the velocity in state 1. This is equal to summation of same masses times the velocity in state number 2. Okay, so let's sum up this. So we have MA EA1 plus B BB1. This is equal to MA plus B, okay, times V2. So here we'll have 15,000 by E1, which is 1.5 plus 12,000 by VB, which is just a minus 0.75. This is equal to 15,000 plus 1,000. Okay? So this is minus because part is going in the opposite direction, right? So making V2 subject to the formula, we'll have 15,000 by 1.5 minus 12,000 by 0.75 divided by 27,000. This gives us a 0.5 meters per second. Okay, 15,000 by 1.5 minus 12,000 by 0.75 divided by 27,000. So this is V2. So now we are being asked to find the total energy before and after the coupling. Alright, so let's say for this state 1, state 1 we are calling it E1, energy in the first state. Let's find this. So I'm saying E1, we are just concentrating on kinetic energy. This is equal to half m squared. This is equal to half ma va squared plus half mb bb squared. And therefore, E1 is just half. We can factor out this. MA is just a 15,000. BA is 1.5 squared. Okay, plus 12,000 by minus 0.75. Whether is minus positive because we are squaring. Therefore, our E1 is going to be equal to 15,000 by 1.5 plus 12,000 by 0.75, then by 0.5, that's a 20,250 joules. So 15,000 by 1.5 squared plus the 12,000 by 0.75 squared, okay, by 0.5, 20,250. Right, so let's go to state number 2. State 2. State 2, here we are dealing with E2. Okay. So E2, here we have E2 is equal to half A squared. This is equal to half MA plus MB, MA plus MB, and this times E2 squared, right? In E2, this we have half 15,000 plus 12,000 by V2. And here we found our V2 is equal to 0.5. Okay, so we are going to factor in our V2 there like so. For our E2 is just going to be equal to 15,000 plus 12,000 by 0.5 squared by 0.5, and this we get 3,375 joules. Alright, so let's now calculate the difference in the kinetic energy. So the difference in the kinetic energy, I'm just looking at absolute values. Okay? Delta E just equal to 1 minus E2. Doesn't matter if you say E2 minus. So this is 20 to 50 minus 3375 minus 3375. This just becomes equal to 20 to 50 minus 3375. It becomes 16,875 joules. Right. So let's do an explanation here. So kinetic energy 2 uses, okay, because part of the energy, okay, so part of the energy, okay, this one that we calculated 16,875 is dissipated as heat, sound, deformation, and so on. Okay. However, the total energy is conserved. Total energy includes, it includes heat, sound, deformation, kinetic energy, and so on. Okay. I think this is about it. So we have two. We have E1, this is kinetic energy in the first state. We have E2, this is kinetic energy in the second state. And then we have this difference in energy. And then finally we have this. Okay. have this energy. Alright, I think this is really about it. This is really about it. So I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.